Bismillahirrahmanirrahim. In this video, we will solve numerical problems for unit number 13, Electrostatics, Physics 10, National Book Foundation. This is problem 1 and it requires you to calculate number of electrons that contain 100 picocoulombs of charge. Now the given is charge 100 picocoulombs, which is equal to 100 into 10 power minus 12 coulombs. The charge on an electron E is equal to 1.6 into 10 power minus 19 coulombs per electron. Now you need to find number of electrons, that is N, and the formula used for this purpose is Q is equal to NE. Now the solution is, first solve for N, that is the number of electrons. N is equal to Q over E. We take this E to the other side and isolate N and write it as N equal to Q divided by E. Now substitute the values. Q is equal to 100 into 10 power minus 12 coulombs and E is equal to 1.6 into 10 power minus 19 coulombs per electron. Now substituting these values and then calculating using a calculator results in N is equal to 6.25 into 10 power 8 electrons. Problem 2 is, find force between 2 point charges each of 1.2 picocoulombs and 2.5 picocoulombs placed at a distance of 50 centimeter between their centers. The given data is Q1 is equal to 1.2 picocoulombs, which is equal to 1.2 into 10 power minus 12 coulombs. Q2 is 2.5 picocoulombs. Converting it into coulombs is 2.5 into 10 power minus 12 coulombs. Distance R is given as 50 cm. Converting it into meters, 50 divided by 100 meters, this is equal to 0.5 meters. And the coulombs constant K is equal to 9 into 10 power 9 Newton meter square per coulomb square. You need to find the force F. Remember, you must always change the data given to SI units and the values in prefixes into the SI unit values, that is coulombs. Solution. The electric force between 2 point charges is given as F is equal to K Q1 Q2 over R square. Now substitute the values given. F is equal to 9 into 10 power 9, then 1.2 into 10 power minus 12, 2.5 into 10 power minus 12 and 0.5 square. Now carrying out the calculations, you reach your answer. Force is equal to 1.08 into 10 power minus 13 Newton. Problem 3 is, force of repulsion between two identical point charges is 100 Newton when distance between them is 40 centimeters. What is the force of repulsion if distance is doubled? Now the given data is force is equal to 100 Newton and distance R is equal to 40 centimeters. To find force F when distance is doubled, this is to be found. Now formula is F is equal to K Q1 Q2 over R square, where Q1 and Q2 are two charges. K is the coulombs constant, which is 9 into 10 power 9 Newton meter square per coulomb square. Now the solution to the problem is, since the electrostatic force is given as F is equal to K Q1 Q2 over R square, and if distance R is doubled, means R becomes 2R. other quantities remaining same, the new electrostatic force F dash can be written as F dash is equal to K Q1 Q2 over 2R square. Now squaring the denominator results in F dash is equal to K Q1 Q2 over 4R square. Isolating 4 from here, it can be written as 1 over 4 K Q1 Q2 over R square. Now substitute K Q1 Q2 over R square equal to F from the original formula written here, that is the original force given. Now since F dash is equal to 1 by 4 into F, substitute F is equal to 100 Newton given. And then F dash is equal to 1 over 4 into 100. Now calculating this results in F dash is equal to 25 Newton. This is the required force when distance is doubled. Now you must have noticed that I have not used this distance of 40 cm into this calculation. If I use this 40 cm converting it into 0.4 meter, I would be doing an unnecessary calculation which I can avoid and make the problem rather simpler. Doing this calculation of 0.4 meter with this 100 Newton on the other side and making this solving this problem will make it a little more cumbersome and difficult. This is an easier approach. And notice there is a problem, there is a question, conceptual question number 5 in the same unit. And if you have seen my video on the conceptual questions from question 5 to 10, you will notice that in that question 2, I do not use any values. Rather, I only use this double and halving the quantities and reaching the correct answer with a very simpler approach. Problem 4. Two identical charges 10 cm apart experience a force of 250 Newton. What is the magnitude of the two charges? Now the given data is distance R is given 10 cm, converting it into meters, 10 over 100 is equal to 0.1 meter. Now force F is given as 250 newtons and K we know that it is 9 into 10 power 9 Newton meter square per coulomb square. Now the formula used is F is equal to K Q1 Q2 over R square. We need to find Q1 and Q2. Note, since the charges are identical, so let Q1 is equal to Q2 is equal to Q. Since charges are same. Now the solution is, substitute the given values in the formula given for electrostatic force. That is 250 newtons is equal to 9 into 10 power 9 times Q dot Q over 0.1 square. Swap the sides to write it as 9 into 10 power 9 Q dot Q over 0.1 square equal to 250. Now move the numbers on left hand side, these numbers on the left hand side to the right hand side and write Q dot Q as Q square. Like Q square is equal to 0.1 square divided by 9 into 10 power 9. This number in the numerator above will go in the denominator and 0.1 square in the denominator here will go in the numerator on the other side. Multiplied by 250. Now since it is Q square, you need to find Q. Take the square root on both sides. So Q will become square root of all these values. Now using a calculator, calculate and you will reach an answer. Q is approximately equal to 1.67 into 10 power minus 5 coulombs.